All right. Easy peasy set of rules. Here's the next batch. All right, here's the easy peasy set of rules. Start in your lab. Let's see. Let's look. Some of you might already be there. Start in your lab. Where is that lab? Doggone it. Where did I put that slide thing? I'll just open it. Okay, there we go. All right. Molecular compounds. Now, molecular compounds are way different, and they're really easy to write. Formula's 4. So let's talk about molecular real quick. I saw some of you taking notes in your lab notebook on what we're doing here today, which is actually a really good idea, because remember, on the final exam, you get to use your lab notebook. Final exam for lab, I should say. Not the final exam for lecture, but the final exam for lab, you get to use that whole notebook. So if you got a nice, consistent set of notes in your lab notebook that you can use on the exam, life is going to go better, right? So write everything you can in there, in that lab notebook that you can now. Okay, molecular compounds are also known as covalent. And these are the things that are the true molecules, the things that can exist on their own. So they're not a repeating crystal structure like an ionic compound, right? Let's look at the structural differences between the two. We look at ionic versus covalent. Ionic compounds like sodium chloride are big, giant, repeating crystal structures with multiple units that add up to a compound. So we have lots of NaCl's this way, lots of NaCl's this way, and lots of NaCl's this way. We write it as sodium chloride because it's the lowest whole number ratio of atoms in the compound. We don't write Na437Cl437, right? We just write NaCl, okay? These are large crystal structures that are three-dimensional. They cannot exist as a single unit of NaCl. So you can never call NaCl a molecule. It is a formula unit. And we call it a formula unit because it's just the lowest whole number ratio of an ionic compound. Covalent compounds are different, though. Remember, ionic compounds are metal plus nonmetal. Covalent compounds are nonmetal plus nonmetal. Covalent compounds are true molecules, meaning something like H2O or CO2, right? Those are individual molecules that can exist on their own apart from everything else. They don't have to have a crystal structure. So you can have a hunk of H2O floating around this room as a vapor. It doesn't have to be connected to other H2O. Same thing with CO2. You can have CO2 by itself. It doesn't have to be connected to other things. All right, so the rules for covalent compounds are a little bit different. Actually, they're a lot different. You don't have to worry about charges because they're all negative. So there's no crisscrossing. There's no net charge of 0. You just slap on a prefix. And the prefix system goes like this. Mono. You should write all these down, and probably in your lab notebook would be a good idea. Di, tri, tetra, hepta, let's see, 5, hepta is 5, hexa is 6, oh no, wait a minute, 5 is penta, what am I thinking, penta, hexa, it's been a while since I had organic chemistry, penta, hexa, then hepta, then octa, nona, and deca. Right, so mono is 1, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Those are the prefixes that you need to remember. You need to memorize those. I always remember, okay, here's mnemonic devices I use to remember these things. Mono. I was married to an Italian fella for 9 years, and when they have a mano conversation, what are they talking about? One-on-one, right? So, okay, so one-on-one. Di, like two. Tri, like a tricycle, has 3 tires, or a triceratops, right? The dinosaur that has 3 horns on the front. Tetra, there's a little tropical fish called a tetra, and guess how many stripes a tetra has? 4. I think that's why they call it a tetra. They also kind of glow in the dark a little bit. Penta, there was a famous structure that was bombed in 9/11, right? The Pentagon. So that's how I remember that one. The Pentagon, guess, has how many sides? 5 sides. Hexa. You guys are probably too young to remember this, but the Omen movies with Damien, the little devil child, he had 666 tattooed on his head that his dad found, and that's when his dad knew he was the devil. So I always think about Hexa. It's like witches and devil and Damien in the Omen movies. Did any of you guys ever see that movie? Scared the bejeebers out of me. Oh man, that was a scary movie. Oh, there's a remake?
Yeah.
Oh, that never turns out well, usually. All right, hepta. There's actually a vacuum that has a hepta filter. How many chambers do you suppose a hepta filter has? I would assume 7. Octa, like an octopus, has how many arms? 8, or an octave in music has 8 notes. I can't figure out one for nona, and deca is like a decade, or a decathlon is 10 kilometers, I think, when they have a decathlon. All right, so you take the prefixes, you slap on a prefix, and off you go. You don't have to worry about charges, you don't crisscross, nothing. Oh, and there are both binary and ternary molecular compounds. Just like there are binary and ternary ionic compounds, but we're going to let OChem have all the fun with the ternary compounds. How many people got to take a year of OChem in here? That was my least favorite chemistry, was OChem. It was all memorization. If you're good at memorization, it'll be a cakewalk. I'm not good at memorization, so OChem was my least favorite. So we're not going to do ternary in here, ternary molecular, and that's because you spend a whole year on that in OChem. We're only going to worry about the binary, so you only have 2 things to worry about. Okay, so I like to do this with a little joke. Start with, everybody knows the common name for this stuff. What's the common name for H2O? Water. All right, the IUPAC name, you got to have the name of the first nonmetal, then the name of the second nonmetal with an IDE suffix, but if you need a prefix, you got to slap the prefix in front of the name. So, you think that's water, but that's the common name. The IUPAC name is dihydrogen monoxide. Dihydrogen monoxide, right? So, I tried to play a trick on my mom once when I was an undergrad in chemistry and I was learning about nomenclature. And I went to the dinner table and she says, all right, here's your supper, Lorelei. So I says, what would you like to drink? And I said, I'd like a glass of dihydrogen monoxide, Mom. And she looks at me, she goes, well, you know I don't serve that sort of beverage in my home. I think she thought I wanted something alcoholic, and it was dihydrogen monoxide. I says, no, Mom, it's just water. And I tried to explain the nomenclature rules for me. And she's like, stop making things so complicated, Lorelei. Just tell me water, right? Okay. So it's dihydrogen monoxide. There was actually there's a website, Ban Dihydrogen Monoxide. You ever seen that? Ban Dihydrogen Monoxide? Ban Dihydrogen Monoxide says things on the website like, responsible for up to 5,000 drownings per year. Primary ingredient that causes swelling in the brain during encephalitis. What's encephalitis? Water in the brain, right? So the component that causes the swelling, primary swelling, encephalitis. It has all these things that we should ban dihydrogen monoxide. Sounds like a good idea, right? Ban it. Sounds like bad stuff. All right, you all know the common name for this stuff. Or actually, the IUPAC name you know for this one. What's this one? Carbon dioxide. What's this one? Carbon monoxide. All right, so you notice the mono prefix is the only one that you have to either choose to use or not to use. If the first thing is individual, you don't have to use the mono prefix. So you would not call this monocarbon dioxide. You simply call it carbon dioxide, right? You don't call this monocarbon monoxide. You only use the mono prefix if the second thing is singular. Okay? So it's carbon dioxide or carbon monoxide. You drop the mono prefix if it's the first thing, but you got to keep the mono prefix if it's the second thing. Let's try a few more. Here's very toxic stuff. This stuff. What's the name of this stuff? The IUPAC name for this? Carbon tetrachloride, known carcinogen. You can see a big drum of that out in the desert. Get the heck out of there and call the OSHA or the hazmat team to pick up the carbon tetrachloride. That's the easy part. So the molecular or covalent compounds in this class, they're always binary. You slap on a prefix, add ID as a suffix, and off you go. All right, one more set of rules I'm going to teach you because I know you all love those easy peasy rules and you're just going to zip right through those. So please don't be doing the easy peasy rules while I give you these rules for acids, okay? Because the rules for acids are not easy. So you definitely need to listen. So take a look at whatever page this is in section 7 when we're talking about acids. And we're going to use the rules for acids. I'm going to give them to you short and sweet because that's how I remember them. Short and sweet. We got acids. We have binary acids. And we have ternary acids. All acids have what in their formula? How do we know that something is an acid? By simply looking at its formula. Hydrogen in it. Okay. So let's sort these. I got, there's an acid. There's an acid. That's an acid. There's an acid. And now I know these are all acids because I'm going to put AQ next to them. Because you might think that they are molecular compounds. But if you put the little AQ next to them, then you know that they are acids. All right. So which one of these are binary acids and which one of these are ternary acids? If we were going to sort these into bins, which bin would I put HCl in? Is that binary or ternary? Binary. Okay. What about H2SO4? Ternary. HNO3? Ternary. HBr? Binary. And H2S is binary. Okay, so you guys got that one figured out. Binary acids have one set of rules. Ternary acids have a whole, different set of rules. And you got to make sure that you use which with which. Binary acids, make sure you're putting this in your notes. You use the hydro prefix, the name of the anion goes here. You add IC as a suffix, and then the word acid. So binary acids are always hydro something ic acids. So let's practice that. Hydro something icking the acids that are binary here, right? All right. What's the name of this stuff if we use our rules here? Hydrochloric acid. All right. What about this one? Hydrobromic acid. And this one would be? Hydrosulfic. Yeah, hydrosulfic acid. Sulfuric would be okay, but hydrosulfic would be better. All right, easy peasy, right? Hydro prefix, name of the anion, IC suffix, and the word acid. Easy peasy. Ternary acids, a little bit more difficult. All right, and here's what you're going to write down for ternary acids. 8 to ic and ite to us. Write that down, and I'm going to show you how we use it. As you're driving home from class tonight, I want you to say that 50 times on the way home as you're driving. Because you shouldn't be on your cell phone, you shouldn't be messing with the radio or your makeup or shaving or, whatever. You should be looking at the road, but you can certainly talk or sing, right? So as you're singing and talking and you're driving, you go 8 to ic, ite to us is the rules for ternary acids. 8 to ic, ite to us. 8 to ic, ite to us, right? Okay. Here's how that works. 8 to ic, ite to us is the rules for ternary acids. Let's use our ternary acids that we have here. I'm going to have a couple different ones. All right, we got some ternary acids. Now, ternary acids, you have no hydro prefix. So don't hydro anything, these acids, all right? No hydro prefix on any of these. You take ate to ick, ite to us, and add the word acid. I'll put that rules up here. Ate to ick, ite to us, plus the word acid. So, SO4. Look at your list of polyatomic ions. What's the name of SO4? Is sulfates, right? Sulfate ends in ATE. The rule is ate goes to ick, so we call this sulfuric acid. No hydroprefix. Ate to ick, ite to us. SO3. What's SO3 called? Sulfite. The rule says ite goes to us. So we're going to call this sulfurous acid. Not so hard, right? Let's do a couple more. Ate to ick, ite to us. Remember, that's our rule. NO3. What's the name of NO3 as a polyatomic ion? Nitrate. It ends in ate. Ate changes to ick, so I'm going to call this nitric acid. You guys are going to be such experts. You're going to start looking at the back of packages and things that you eat now, and you go and go, holy smokes. There's an ionic compound. There's another ionic compound. There's a third ionic compound. And look at that, there's an acid. And you're going to say, I'm eating ionic compounds and an acid. Look at a Gatorade bottle. It's fascinating how many ionic compounds they have in Gatorade. What'd you find in your Pepsi bottle? Anything?
Phosphoric.
Phosphoric acid. Coca-Cola is very acidic. When I taught junior high, students would do science projects, and there was a girl whose dad was a dentist, and he saved a bunch of extracted teeth. And she took the extracted teeth and put them in different soda pops, Sprite, ginger ale, Coca-Cola, root beer, etc. And the one that was the most corrosive to the teeth was the Coca-Colas, because they have those acids in them. And they actually will, she weighed the teeth before she put them in the sodas, and then plunked them in this, and she'd weigh them every week to see how the mass decreased based on the decay. And the Coca-Cola is the worst. I've also heard that you can take Coca-Cola and use it to get bugs off your windshield. It is so acidic, and the bubbles and the sugar. If you have a whole, you're going on a big long road trip and you got a bunch of bugs stuck to your windshield, take a Coca-Cola, pour it across the windshield, put the windshield wipers on. Apparently it takes all the bugs off. It'll take the rust off a penny too. Wow. Fascinating. I didn't know that. Another new piece of information. I'll have to put that one in the memory banks. All right. NO2. What's NO2 called? Nitrite. So if we're using our rules for ternary acids here, ite would go to us. So this would then be called nitrous acid. Did you guys hear the thing on the news about Hurricane Harvey, and there was a chemical plant that they are concerned is going to explode? Did you see that on the news? No?